We've been looking at the idea of sequences, which is just a list of numbers in a particular order. And today we're going to move into a series. If we have an infinite sequence, a sub n, so an infinite list of numbers, and then we add the numbers in that sequence up, we create a series. If we only add a certain number of those elements up, then it's a finite series, S sub n, represented with the summation notation. But if we add up an infinite number of those terms in the sequence, we create an infinite series. Be careful. It's very easy to interchange those words. You may even find me doing it in this lecture. But remember, a sequence is the list of elements or numbers in a particular order. And the series is the sum of those elements. So be careful when you're looking at those two terms. Notice here that the term infinite refers to the infinite number of terms that appear, but it doesn't necessarily mean that the sum itself is infinite. And let's look at two examples of what happens there. We've already looked at our summation notation, and here we're going to look at two infinite series. So we're adding an infinite number of terms, and we're going to decide if the series converges or diverges. Converges just means that it's going to go to a single number. Diverges means that it's not going to approach a single number. Let's begin to look here. If we list the first few terms, S sub 1, so that's the sum of the first term in the sequence, creates the series S sub 1, is going to be 1 over 1 minus 1 over 1 plus 1, which gives us 1 over 1 minus 1 over 2, which results in 1/2. If we calculate S sub 2, notice we're going to have 1 minus 1/2 still, plus the second term in the sequence is going to be 1/2 plus 1 over 3. And if we combine those, notice we're going to get 1 minus 1/2 plus 1/2 plus 1/3. And we can think of that as 1 minus 1 over 2 plus 1. And you're going to see the reason that we're thinking about that here in a minute. I'm going to circle here. Notice this was the S sub 1. This is S sub 2. If we look now at the partial sum S3, we have 1 minus 1/2 plus 1/2 minus 1/3 plus 1/3 minus 1/4. And what you'll hopefully start to see is these terms are going to cancel, and we end up with 1 minus 1 over 4, or we can think of it as 1 minus 1 over 3 plus 1. And hopefully you'll start to see the patterns there, that we can write this series S sub n as 1 minus 1 over n plus 1. Well, as this term gets bigger and bigger, as we get closer to infinity, this term is going to go towards 0. And so we can see that this series, the partial sums, are going to approach 1. And therefore, we say that the infinite series converges. Infinite series, but it moves towards a single value. If we look at this one, the pattern will most likely be visible a little quicker. Our S sub 1 is going to be -1 to the first. S sub 2 is going to be -1 squared, which just comes, and I left out my first term there. Our S sub 2 is going to be that first term plus -1 squared, which results in -1 plus 1, which goes to 0. S sub 3, we're going to have -1 to the first, plus -1 to the second, plus -1 to the third, which results in -1 plus 1 plus -1. Notice these cancel, and I end up with -1. S sub 4, I think you'll recognize quickly, becomes -1 to the first, -1 squared, -1 cubed, -1 to the fourth, which gives us -1 plus 1 plus -1 plus 1, which comes out to 0. And so we can see that our series can be written as -1 or 0. It's -1 if n is odd, and 0 if n is even. Thus, it does not approach a single value or a fixed number as n gets very large, and it instead oscillates between -1 and 1, and we say that the series diverges.